Okay guys, today's lesson is on graphing lines that are in slope-intercept form. So what we're going to be doing today is taking an equation of a line and graphing it using the equation. So here's an example of a linear equation, y equals 2x plus 4. And this is already in what's called slope-intercept form, meaning the slope and the y-intercept are visible in the equation, and that's what we're going to use to graph this information. So the old way of graphing these lines might have been making what's called a t-table or an input-output table, where we have a two-column table for possible x and y values, and we sort of plug in different x's and figure out what y would be. So for instance, I could make up any number for x that I want, say 0. So x is 0, I'm basically plugging 0 in for x and solving for y. So if x were 0, I would get 2 times 0 is 0, plus 4 is 4, so y is 4. And that's one column in my, or one row in my t-table. And it represents a point. When x is 0, y is 4. That represents a point on the graph. And then we could continue doing that. When x is 1, I plug in 1 for x, and I do 2 times 1 is 2, plus 4 is 6. So y would be 6. And I could do 2. When x is 2, 2 times 2 is 4 plus 4 is 8. So these represent points on a graph, and this is one way to graph a line, and it's probably what you've done before you learned about slope-intercept form. So I'm going to go to this next page, and I'm going to show you on a graph. I'll recopy that same equation, 2x plus 4. And instead of making a t-table and plotting all those points, we're going to use the slope and the y-intercept. So if you remember, this should be review, but that number right there is the slope. Whatever's being multiplied by x is your slope. It tells you how steep the line is or how far to go up for every move over on the x. It's your rise over your run. That number right there is your y-intercept. It's where it crosses or touches the y-axis. So here's my y-axis, here's my x-axis. So what you want to do when you're graphing this is start with the y-intercept, because that's a point on this graph that we know and we can plot immediately. It crosses the y-axis at 4. That's right here. That's a point that's really easy to plot. So you always start by plotting the y-intercept, and that's whatever's being added or subtracted. If that were minus 4, we'd go down to negative 4 on the y-axis. Okay, now we're going to use the slope. So since the slope is 2, and remember on a graph, the slope is rise over run. So if my slope is 2, we can think of that as 2 over 1. That means from any point, from one point to the next point on this line, we're going to rise 2 and run 1. That means we're going to go up 2 from this point and then over 1. And we can continue to do that to get more points, because that should be the same slope, the same kind of incline, no matter what 2 points I go between. So if I want to start at this point right here and go up 2 over 1, I would land right there. Okay, if you run out of room, you can go backwards. But remember, a positive slope would always be and over. When I say over, I mean to the right every time. Over always means to the right. So this line goes up and to the right, but if you run out of room, you can go backwards as long as you go backwards with both. So instead of up, we can go down, and instead of over, we go to the left, backwards. So that's okay, and as long as all those points still fall in a single line, you should be okay. So generally you want 3 to 5 points plotted, and then you can connect them with a line. The arrows are very important, so make sure you put arrows on the end of your lines every time. That indicates that this pattern will continue in both directions forever. Okay, so let's do another example. Let's take y equals 2/3 x minus 5. Okay, so we're going to start with labeling everything. My y-intercept is negative 5. and my slope is 2 over 3, meaning my rise is 2, my run is 3. So up 2 over 3 is what that means. So since my y-intercept is -5, that's where I start. So this is always where you want to start graphing with your y-intercept. So plot that point. That's where it crosses the y-axis at -5. That is right there. That point right there is -5 on the y-axis. Okay, now we're going to use the slope to get some more points. So since the slope is 2 over 3, that means from this point to the next point, I'm going to go up 2, and then I'm going to go over. When I say over, I mean to the right, 3. And then that lands me on my next point. And I can continue doing that from one point to the next. I can go up 2, over 3. That lands me on the next point. Up 2 over 3 would land me right there again. Once I get a few points, if I want to go backwards, I can come back to this point and go down 2, left 3. As long as you go backwards for both the rise and the run, you're still in the same line. You're still okay. And then connect your lines, draw arrows on the end. And that is the graph of the line y equals 2/3 x minus 5. Okay, let's do one more example. Y equals -1/3 x plus 2. So in this case, my y-intercept is 2, and my slope, or my rise over run, is a -1 over 3. Now this time I'm going to have to pay attention because my slope is negative. That means I'm going down instead of up, but I'm still going to start with the y-intercept. Y-intercept is +2. That means it crosses the y-axis at +2 right there. That's your y-intercept. And then we're going to use the slope to get from one point to the next. So a -1 over 3 means go down 1 over 3. Just like that. So down 1 and then over 3. So from this point, I'll go down 1 over 3. Down 1 over 3. And that's how you keep going down 1 over 3. So again, I'll always make the run positive if I can fit it, meaning I'm always going to the right. And if it's positive, the slope is positive, I'll go up and over. And if the slope is negative, I'll go down and over. That's why I keep going down 1 over 3. And you're done with that line. Get 3 to 5 points plotted, and then you can connect them, draw arrows at the end of your line. So this format right here, when you see a line written like this is called slope-intercept form because you can actually see the slope and the y-intercept. Now, if you happen to have a problem like this, where there is no plus or minus, then what you have is the y-intercept. You do have a y-intercept. The y-intercept is just 0, because you could technically put a plus 0. Your y-intercept is 0. Your slope in this case is -2. So think of that as a -2 over 1, so you know that your rise is -2 and your run is 1. So as you go down 2, you'll go over 1, but in this case, we're going to start at 0, 0, the origin. So when you don't see a y-intercept, it's not necessarily that it doesn't exist, it's 0. It passes through the origin. And then once you plot your y-intercept at 0, you use your slope to go down 2 over 1. There's my next point. Down 2 over 1. Down 2 over 1. Plot a few points and connect the dots. So that is how you graph a line in slope-intercept form, using the y-intercept and the slope to graph the line.